Hello, Mr. Sharo here again. This is video number 3, which covers section 0.2, Algebra 1 Review Day 2, Operations with Fractions. The two objectives that we will cover in this lesson are listed here. Please take a moment to read them, and as you do, let me point out that operations, when we speak of that term, refers to addition, subtraction, multiplication, and division. Before I continue, I just wanted to remind you that before watching this video and completing some of the exercises with the notes, I wanted you to go to YouTube and watch a few minutes, not the whole thing, of the 9-minute video clip with the link listed here. As noted, the video contains some really good images to help those who struggle with operations and fractions to give them a better understanding of why some of these things actually work. Of the 4 operations with fractions, addition and subtraction are widely known as the most difficult for one major reason, and that is what is known as the common denominator. If you take a look at the example underneath this section, you'll notice that the denominators, or the bottom numbers, the 3 and the 7, are not the same. Since they're not the same, we must find a common denominator to add these fractions correctly. So now if we're going to attempt to correctly add 2/3 and 4/7 as shown in this example, we must notice that the denominators are not the same, and we must get them to be the same by finding a common denominator. Now to find that common denominator, as detailed in step 1, we must ask ourselves, what is the smallest number that both 3 and 7 divide evenly into? And this can be the challenge of adding fractions together for so many people, and we will spend a lot of time in class trying to work through those difficulties. But to save time, let's just go through and say, all right, we know it off the top of our head. The smallest number that both 3 and 7 divide evenly into is 21. Now that the common denominator has been found, we must also change the numerators. Any time that you change the denominators, the numerators must be changed as well, and by the same factors. For instance, we ask ourselves, well, how many times does 3 divide evenly into 21? Well, that answer is 7. So what we're going to do is we're going to take the top and the bottom of that original fraction 2/3 and multiply it by 7. So now what was 2/3 will now become 14 over 21. And when we look at the 4/7, well, how many times did 7, or does 7 go into 21 evenly? Well, the answer is 3. So we are now going to multiply the numerator and denominator of that second fraction by 3. This is where we will get 12 over 21. At this point, both steps 1 and 2 are complete. The final step is to simply add only the numbers in the numerator. 14 and 12 gives us 26. And notice the bottom remains as 21. So our final answer is 26 over 21. However, that can be written as a mixed number as 1 and 5 over 21. Since neither top nor bottom of this fraction can be reduced, we would write this as our final answer. In my opinion, the next two operations, multiplication and division, are much more simple than addition and subtraction. Let's start with the multiplication example. Fortunately for us, there is no need for a common denominator. That means while the 3 and the 7 are different in this case, it has no effect on how we do this problem to begin with. So, as it says, it is very straightforward. We go straight across and multiply the top numbers, and we go straight across on the bottom and multiply the bottom numbers together. Doing so in the numerator gives us 8, and doing the same thing in the denominator gives us 21. Once again, this is our final answer because neither top nor bottom can be reduced relative to one another. Finally, for division of fractions, we do not need a common denominator either. So just like multiplication, you don't need a common denominator. If you look at the line here, it's pretty simple on how we divide. Dividing fractions don't ask why. Flip the bottom or second fraction and multiply. So when you look at the problem, negative 2/3 divided by 4/7, what actually happens is the first fraction remains identical, and the second fraction now is the reciprocal of what it originally was, and now the problem has went from division to a multiplication problem. And you might be asking yourself, well, why is that? We can spend, a considerable amount of time in class investigating that, but for now, let's just take the rule as is and complete the rest of the problem. Since this is now a multiplication problem, we will treat it just like the above problem we did, and we will multiply straight across the top and straight across the bottom. So our final answer will be negative 14. Notice negative multiplied by a positive gives us negative, and 4 times 3 on the bottom gives us 12. Now, since both top and bottom are divisible by the same number, we can reduce the fraction by dividing both the top and the bottom by that number. So to reduce negative 14 over 12, we will divide both top and bottom by 2 to give us negative 7/6, and this will be the simplified final answer. So if you haven't already, I'd like you to take a moment to pause this video or stop it and complete the 3 examples on the right side. You can then check your answers by hitting play. Well, how did you do? Here are the answers to the 3 problems I had you work on just a moment ago. Notice that all 3 answers are in their completely reduced versions. Any questions about these problems I can address tomorrow. I will conclude this video with picking out a few random exercises from examples 1 and 2 to show you. Please finish any examples or exercises I did not complete on the video notes and have them ready for tomorrow. We will take any questions then. Let's start with letter D from example 1. Now notice this is a subtraction problem, so we must find a common denominator. To do so, we think, what is the smallest number that both 5 and negative 4 will divide evenly into, and that number is 20. Notice I'm keeping all of the signs positioned where they were at the beginning. Remember, since we changed the denominators, we must also change the numerators by the same factor. So, how did 5 become 20? Well, 5 goes into 20 4 times, which in other words means we multiply it by 4 to get to 20. To go from negative 4 to negative 20, well, how many times does 4 go into 20? It goes in there 5 times. In other words, we multiplied by 5. Well, we must keep that consistent and do the same to each numerator. So the 6 gets multiplied by a 4, and the 3 gets multiplied by a 5. So now our numerators will be 24 and 15. Since our denominators are now the same, we can go to step 3 in the addition and subtraction process and just add or subtract the numerators. Now, if you remember from previous lessons, we have a positive number, 24 over 20, minus a negative 15 over 20. Well, we now have the ability to make this a same change problem because of the 2 subtraction signs in the middle. So now we have 24 plus 15, and that becomes 39. And remember, the denominators in addition and subtraction do not get added or subtracted together. So our final answer is 39 over 20, and that cannot be reduced. Or you may be able to write 1 and 19 over 20 as a mixed number form. The last example I would like to show you today is example 1m. Now, when we look at the problem to begin with, it is -4/7 divided by 3. We are talking about fractions, of course, so we need to make this a fraction by putting the 3 over 1. Now that I have a division of two fractions, if you recall from earlier, we are going to convert the division into a multiplication problem, and here's how you do that. You leave the first fraction exactly the same as it was. We change the problem to multiplication, and we flip or invert the second fraction to 1/3. Now it is a multiplication problem, so we are free to multiply straight across the top and straight across the bottom. This gives us a final answer of -4 over 21. And this is not reducible, so this would be our final answer. Well, you've reached the end of this video lesson. So, before you come to class tomorrow, please complete all remaining exercises from examples 1 and 2. Good luck.